Hi, my name is Matthew Waddington, and I'm a beekeeper in the Pacific Northwest. And today I'd like to present to you a innovation, hopefully, in oxalic acid vaporizers that I think if you have some of the similar issues that I've had with them, you'll find helpful and possibly interesting. You'd like to build one. This is a development that I've thought of, been working on for quite a while. Put a number of time in to get a simple version here. It's very ends up being very simple. Seems to work quite well. This is its first year, so I haven't put it through multiple seasons. But this is going. I think has some real pluses. So let me describe to you real quickly. What I'd like to do is describe to you real quickly how it works and what the advantages I think of using this tool would be over more traditional versions, and also then I'd like to take it all apart and show you how it's put together and how you could build it if you so chose. So, real quickly, it works like most oxalic acid vaporizers in terms of its engine. The powder is put in this chamber here. There's a glow plug with some other things which I'll show you that are internal to this. It has 12 volt or a 12 volt battery. It will connect to. This goes out to some battery clamps. I put maybe 3 or 4 feet of wire on there, depending on how much wire I have around. And it utilizes a bent and shaped brass tube to transport the gas of the oxalic acid. So pluses are that one of the biggest ones is I have a lot of hives that are thin openings. They're 3/8 openings. Maybe a third of the hives I have 3/8 what used to be called winter openings that I can't put a more traditional pan type oxalic acid vaporizer into. It's just too thin of an opening. So my thought was first to develop a hive tool that or an oxalic acid vaporizer that had a narrower opening and use a smaller tube or something, or inject it some way. So this then does that, and I'll show you in a minute how that works. In addition, it has the operation of the heat. This engine of the actual oxalic vaporizer is here, and so it puts it outside the hive, which is kind of a response to something that Rusty Burlew talks about on her website, which was some reported instances of hives burning inside when the glow plug actually went internal to the hive and caught fire on the burr comb or something like that, and destroys the hive. So this puts the primary heat source outside the hive, and this does not get hot enough to, it gets hot, but doesn't get hot enough to ignite wax. So that seems like a real plus. Secondly, unlike some other ones which use an external tube, there's some that use a torch to burn, to heat up a chamber using a butane torch, passing on there and feeding it through a tube into the hive. That it seems dangerous to me, for one, but seems that's kind of set aside here by using actually a 12 volt battery, or 12 volt glow plug, being able to stand away from the hive, have it entirely protected, not being near the hive at all when the operation is going on, and also just avoiding the whole using open flame, etc., etc. So that seems like a real plus. The last real advantage, I think, it has been the simplification of building on. There's a couple little things that are, somewhat complicated, but I didn't use any special tools except, basic soldering skills and bending a few things. So nothing very complicated at all about building on, and relatively inexpensive. I know little parts and pieces add up, but this is pretty cheap to build. Probably the most expensive part is a $10 glow plug, etc. So real quickly, how does it work with the opening? And you have to imagine, for example, let's pretend that we were going to have let's say we had a hive here. This will be the front of the hive like this. So front up here. Let's say we had the front of a hive. Let's see if we can flip that around here, like that, and then we had the bottom of a hive, say here. Sometimes, and so what you're seeing here, let me just back that in a little bit. What we're seeing here is a small opening, much smaller than 3/4 of an inch, which is this width here, and that has been proven to be so. If you see the picture here too, also this is the landing of the hive. Say bees are landing here, climbing in and going up into the hive that way. So this is sometimes 3/4. It's not a problem, but in some hives, in many hives, it's smaller, and it is a problem. So you want something that will get in there. So the advantage of this is that if I do that, this actually enters into the hive like this. Even with the bent wedge, which actually, this is a new thing for me in this particular model. I haven't actually tested that piece, but you'll see why I'm doing it. And shoves into the hive like that. It goes tight, and you turn it on. You let the heat go on. The heat, the flame or the gas exhausts out of this area into the hive, and it's finished, and you pull it out. So just having that ability to be able to go into hives that are small openings seems like a real plus. And having, again, the heat source, the primary hot part of this thing, outside the hive seems like a real plus. This tube does get hot, and it's not something you would grab. And I'm thinking about some innovations of like being able to have a handle on it or something like that. Not big. I've never had a problem with it, but that I usually wear a glove. That's why. But it'll cool pretty quickly, or spray it with water and it cools off. But that's one thing about it. In bigger openings, this is a little loose, so maybe there's a wedge or something like that happens. But that's all down the line. So that's really the plus of the tool, I think, the two of them. The other plus, as I mentioned, is the construction of it, which is very simple, and I will show you that really quickly. So I'm going to just go ahead and break this down. You'll see, again, there's a hose clamp here, a negative ground wire to the battery, which doesn't matter if it's positive or negative, it's a circuit. So a terminal and a terminal on the tail of that, you'll see, and then a nut and the glow plug, and then I'll open that up. So taking off real quickly the hose clamp. The hose clamp that you want to use, if you do this, is a small one. Get as small as one you can. I don't mean the diameter. The diameter is what it is, but the actual width of this hose clamp is a narrow version. You're trying to minimize the amount of metal that you start having to heat up with your glow plug. So that's been the really issue with this. So taking that off, and then this is, I only put this on finger tight. This is the tail of the nut that comes with the glow plug. Actually, I have a couple washers here because my terminals are I made them a little bit large for what I need to do here. So that's that. So again, there's the nut of the glow plug, which I'm going to put back on right now, and a couple washers, which are not totally necessary. The couple terminals, just those wire crimp terminals on the end of a wire. This is 16. I think this actually this is 14 wire that I've heat taped together, but it could be any wire, and I think even 16 wire would be fine. So just work. And I put about 3 or 4 feet on there because I try to run these together in pairs. So that's that. So here's then is the rest of the thing by itself, and the more difficult part to make. Not super difficult though. So this is a 12 millimeter 1.25 pitch nut, and this is which matches the threading of this particular glow plug. You have to make sure they match each other if you're using a different glow plug. The seal of the whole thing happens here. So basically, what happens in the function of this is that you put in powder into the tube from the top and shake it down or knock it down, just loose down into the chamber, which is down here of the actual where the glow plug is. You apply heat. That glow plug starts heating almost immediately. You'll hear it boiling or starting to boil, and pretty quickly it'll dehydrate the water, or the water will exit the actual powder. So then it really starts boiling. You'll hear that, and steam and gas will come out in a pretty big volume, and then the water goes away, and the powder actually then really sublimates and becomes the gas that you are trying to treat with, and you'll hear it boiling and it turns into lava. Well, while all that's happening, even though the powder might be down here, it's bubbling up and up to the top. So this length of this particular chamber has to be a certain length that the fluid doesn't go up and out exit as it's working in there and spill into your hive. So this is about 3 or 4 inches. Seems about right, but it could have been a little bit shorter. I mean, there's a balance here. The really thing you're trying to do in any of these designs is that I have found is minimizing the amount of metal that glow plug has to heat up, and this is quite a bit. There's a nut here and some thin wall tubing, and that adds up. But this balance in this case seems to be about right. Like, sure, could be lessened. The curve could be tightened. There are lots of things that could be made less, but there is a shape here or a volume here, which is probably about that much, which is like 3 inches, that has to be maintained to make this successful. So this is pretty much it. And if you pull out the glow plug, just like this, it's finger tight in there, but I would use a wrench to tighten it initially. It's really important that seal remains tight. That's the whole reason this is working, because there's no openings that fluid will drain out and hit the hot glow plug and start causing a sublimation outside the hive. So that's important. It might even be that using a copper washer there might help if there were some problems with sealing it. I haven't had a little bit of a problem sometimes. I just tighten it up against the nut, against the glow plug itself. So when I take this glow plug out, you'll see what I have inside here, which is basically the glow plug has an extension on it, which is a couple inches long, which is just a piece of copper tubing with the same, and it's just a friction fit. I hack on or pound it a little tiny amount just to make it friction fit, because basically the end of a glow plug has about a 0.25 OD on its tip, and I just buy a piece that matches that. So this is a 0.25 ID and this is a 0.25 OD, and they fit nicely, and that goes there. So what that does is extends the the action of that glow plug up into the tube further, and I think is a real plus in the sense that the fluid, as it starts rising up in this tube, has more heat directly in contact with it, and so it causes the function to happen quicker. So that's the whole intent there. You see it's just soldered, the tube itself is just soldered directly. I wired that back inside the tube and sanded off the face of the nut to make sure I have good contact, and then soldered it on. So pretty simple, and it goes fine. It seems like it's very durable. There you go. So that's the whole motor of the device. This is the more complicated part. Not complicated, and I like a machine shop, so this is just using carpentry tools and hammers and a couple things like that. But basically, this is a piece of K&S tubing. I think this is a 5/8. The only real reason it has to be 5/8 or any size is that you just want to make sure that it'll cap the end of the wire nut. The nut when you put it on there, and not be bigger than the nut or smaller than the hole. So that can for sure go inside. So that's just soldered on to the tube. So I do that when it's all straight. I solder the nut onto the tube when it hasn't been bent yet. Then I put a 12 millimeter. This is a 12 millimeter 1.25 pitch nut, which is, again, has to match the threading of the glow plug. I put a 12 millimeter 1.25 pitch bolt into that just to cap it. And again, this is imagine this being straight. I fill the entire piece with with salt, just a table salt, the real cheap table salt. Tape the end, just masking tape, and then I put this on a roller or on a EMT bender, but it could be over a dowel or whatever. I mean, it doesn't have to be beautiful, but of course, but if you had more technology there or tubing benders, you could make a really, really pretty one. I just kind of hacked it a little bit here, so it looks kind of primeval, but that's it. And so then the critical part is this is about 45 degrees or something like that. It's not 90 and it's not 0. If it's 0, all the fluid pours out. If it's 90, then sometimes that's a problem if you have hives that are low to the ground. And it also, depending on how tight your curve of your bend can be, it makes the tubing longer. So this is kind of a compromise between having too long a tube, because the arc would be quite a bit bigger, and being able to have access to it, have the wires not hitting the dirt if a hive is close to the ground. But there's, you know, that could be different things there. And then I flattened it out just by putting it on its back and hammering it while it was full of sand to be a diameter that I think, or a width here actually, that I think will work for my hives. It could be thinner. It could have been left the way what it was. If it was just 3/4 inches, it would just fit fine. On the tail of it, I've actually flattened it out and then curved out that part, bent it at a 45-degree angle, and then just soldered that tip. My thinking is that one of the things I was finding, and it might be not a big deal, is that the gas exits here and pretty dynamically shoots out. But sometimes it felt like it wasn't rising, like the temperature of the hive was, I don't know, the flow wasn't happening. I wanted to shoot up inside the hive, and so this is a thought here. It's just making sure it's not going down into the, say, into your mite screen or something, and you know, crystallizing all down there rather than up internally to there. So that was kind of his thinking here. Certainly, the amount of oxalic acid you use, which is kind of, you know, 2 grams a hive or colony, is kind of arbitrary, I think, because, you know, it's not like the system where you are putting it directly on the bees. It's going everywhere, including down into your mite screen and such. So I kind of question whether or not 2 grams, if you put 2 grams in a machine like this, if it's actually functioning that way as well. So I don't know, I have to play with that. But to fill this is pretty much, well, it's really easy when it's cut straight. And I haven't, again, experimented with a tip like this, but pretty much I make a mark on the end here, and just just push that into the oxalic acid powder itself, and then pull it out. And it just puts a plug in there, and then I knock it down inside the hive, knock it down inside the tube until it gets down here, and you know, just kind of shake it that way and hit it with a piece of wood. Sort of. That's it. There's no you know. And I'll take a piece of wire and I'll just clean it out every once in a while just to make sure it's not plugging up. Certainly, one of the problems is, and people have talked about, is that if this is cold and the hot gas is coming out, it starts crystallizing here. I have not had that problem with the wider diameter pipes of the tubing. When I use a smaller tubing, say some of the you know, experimenting with a tubing such as that, which is like you know, 1/4 inch tubing, almost immediately within 2 or 3 tries it would condense here, crystallize, and just plug. I found that to be really ruled out smaller tubing, and the bigger tubing seems to work quite well. Of course, an advantage of this device as well, or this version of this device, is that it's not capped on the end. You can always pull out the glow plug and clean out the tail, or make sure it's good. I don't know what a whole season of using this will do if it'll cake in there, but it wouldn't be very difficult to burn off at all, or to clean out at all. So that's really the primary part of this glow plug, or the description of it. And I think it's pretty cool. I think this will be a keeper tool that I will use for a while. I want to say one last thing about the tubing, and then I have experimented with a number of different kinds of tubing, and it's not, in the soldering part is a little, you know, not that difficult, but I think it stays fine. I was concerned at first that it would fall apart after it heated up, but haven't had that problem. But there are alternatives to it. And one of the things I was experimenting with was using an aluminum tubing, same kind of 1/2 inch diameter, flattening it out, and using a JB Weld type epoxy, high heat epoxy. Oh, this is actually not high heat. Putting the nut on the same way, wiring, I put a kerf on the nut itself and wired the nut before I put the epoxy in. So it just had that kind of a little bit of friction connection there, a positive connection, and then epoxied it all together. It's very important that the nut is grounded to, in both cases, is grounded to the metal of the tubing, because that's the way it gets ground back to the glow plug, because the threads have to be grounded. So anyways, this worked quite well, and super easy. This is about a $9 bunch of stuff that looks like that I used, a JB Weld steel stick, and just remodel in there overnight. Turns hard and you can shape it, etc., etc. Worked just fine. I thought that the aluminum tubing actually had an advantage to it. It cools off a lot quicker. It doesn't pull the heat. It doesn't get so hot that it can't keep heat, but it doesn't get so hot that you can't pull it out within minutes, and almost by hand. So I think just the specific heat, I believe, is the reason that is. It's different for brass and aluminum, and so there might be some advantages that are worthwhile doing aluminum. I would have done it that way, except that I don't have the ability to solder or braze or whatever, or weld a nut to aluminum. I'm sure people out there do, or understand how to do it, or machine something that would work. But really, you don't want a mass. I've tried all sorts of things on the bottom of this to start this, and copper definitely does not work. It totally takes too long to work, and if you try to do copper all the way along, it's just, you can't get thin enough to make it heat up quick enough. So one of these two seem to work, are fine. I'll use this, continue to use this glow plug, or this vaporizer in tandem with this one, and make more as I proceed. You can see this one had a straight edge as well, so it just shot right out. Maybe there's a way of doing that to bend it cleanly, I don't know. So that's pretty much the whole shooting match. That's and you can see it's pretty simple to build, simple to make. Durable as heck, so it's not gonna, you don't have to worry about throwing it in your truck or anything like that. It's just all good. So yeah, there you go. Thanks very much.